All right, so the good news is that if you know how to do a 3x3 determinant, then you know everything you need to know for this section as far as like the basics, okay? What we're going to learn today is different ways to apply determinants. So there's 3 new ways to apply a determinant. The first is to find the area of a figure formed by 3 xy coordinates. The second is to determine if those 3 coordinates would be collinear. And the third is using determinants to solve a systems of equation. The first is finding that area. So if you had 3 points, 3 xy coordinates given to you, and it asks you to find the area of the triangle that are formed by those 3 points, then you would list all the x's in the first column, all the y's in the second column, and then you'd fill the third column with 1s, and then you'd find the determinant of what's there. Whatever number you get at the end, you're going to multiply by 1/2 and make it negative. Make it positive. So whether my initial answer was positive, it would stay positive. If my initial answer is negative, it's going to turn positive because you can't have negative area, okay? So the question came up in the last class, does the order of the points matter? The answer is no. It doesn't matter in which order you put those points as long as the x and y stay together in the individual rows. So it could say something like this. Find the area of the figure with the given vertices. So these are all this could be x1, y1, or this could be x1, y1. It doesn't matter as long as they match each other. So the x's all are going to go in the first column. This would be -2, 4, 2, 3, -1, 5. So x's go in first column, y's go in second column, corresponding y's. And then I fill the third column in with 1. And then I find the determinant of this 3x3. So hopefully you remember from last week, you're going to duplicate column 1 and column 2. You're going to do this carefully, not losing a sign or changing a sign. And then which way do my diagonals go first? Good. Top left, bottom right. So I do -2 times 3, which is -6 times 1. That's -6. 4 times 1 is 4, times -1 is -4. 1 times 2 times 5 is 10. And I get -10 plus 10, which is 0. Then I go back the other way. So 1 times 3 times -1 is -3. -2 times 1 times 5 is -10. 4 times 2 is 8, times 1 is 8. I get -13 plus 8 or -5. And then I would do what I got from the first set of diagonals. So 0 minus what I get from the second one, -5. 0 minus a -5 becomes 0 plus 5. 5 is the determinant. And then for area, I multiply it times 1/2 and make sure it's positive. So 5/2 or 2.5. or 2.5, any of those answers work. All right, so this one says find the area of it should be figure, okay? So now, though, that's obviously not a triangle. How can we do this? Split it into 2 triangles, yes? Does it matter which way my diagonal goes? No, I can have it go this way or I can have it go that way. I certainly wouldn't have it go both ways because you don't want to find the point in the middle, okay? Just pick a way. So if I did it this way, now I'm going to find the area of 2 triangles and add them together at the end. The first one being these 3. So that's -3, 2, -1, -4, -5, -4. And then I'm going to fill the last column in with 1s. Duplicate it again. Top left, bottom right first. -3 times -4 is 12, times 1 is 12. 2 times 1 times -5, -10. 1 times -1 times -4, +4. And I get 6. Go back the other way. 1 times -4 times -5 is +20. -3 times 1 times -4 is +12. 2 times -1 times 1 is -2. And I get 6 minus 30. which is negative 24. Area is always positive, so I'm going to change that to a positive 24, multiply it times a half, and I get the area of that side of this figure is 12. Then I got to do the other side. So now these three, negative 3, 2, 1, 2, and negative 1, negative 4. Again, the order there doesn't matter. Fill the column with 1s, duplicate the first 2 columns. Top left, bottom right. Top right, bottom left. And I get negative 12 minus 12, which is negative 24. Multiply it by half, make it positive, and the area of that side is 12. Which means the area of the whole figure is what? 24. There's no unit on here, so if it was like, it would be unit squared. If this was on a graph paper in which each box represented a centimeter or an inch, obviously then you could do it in those terms. So something that hopefully you remember from geometry, okay, could have actually helped us do half the work here if you remember these things. So that initial shape, right, it looks like it could be a parallelogram, but I'd have to be sure it's a parallelogram before I say, okay, if I only have to find half of it, I could find the other half. So to do that, you have to remember what makes a parallelogram, other than both sides being parallel. So you could have found the slopes of the two pairs of sides and make sure that they were the same. The top two would be easy because these are both horizontal, which means they're already parallel. Okay, so you could have found the slopes of the other two sides, and you would have found them to be parallel. This makes it a parallelogram. The other thing is that if the same pair of sides are both parallel and congruent, and these are horizontal, which means if I had just found the distance here, it would be 4, and the distance here would be 4. That also makes this a parallelogram. So if the same pair of sides are parallel and congruent, I'd know it's a parallelogram, which means my diagonals are going to be congruent, which means as soon as I cut it into one, it's 2 congruent triangles. Does that make sense? So I could have done half of the work by applying the properties of geometry. If you don't remember that stuff, then you just get to do the extra determinant, okay? Because they won't always be a parallelogram. Questions on the area. So most common mistakes there are not making it positive, okay? Area has to be positive. Or forgetting divide by 2, which one you want to make sure that you do both those things. All right, the second test, or the second application of the determinant, is to see if 3 points are collinear. Collinear means they lie on the same line. So if the area test gives you a 0, if there's no area formed, then these 3 points are collinear, okay? So if I do the same exact first step, I put the x and y's into my matrix, I fill the last column with 1s, I find the determinant, and this time if my determinant is 0, then these are collinear. So you don't have to multiply by a half. It wouldn't matter because if it's 0, it's 0, right? But that's what your test is for, that they form a line or they're the same line. All right, determine whether the points negative 2, 2, 5, 7, and 1, 1 are collinear. So top left, bottom right first. Top right, bottom left, second. I'm going to get negative 5 minus 11, minus a negative 11, which is 6. Are these points collinear? No. So if it's a 0, it's a yes. If it's anything but 0, it's a no. Questions? All right, the last application we're going to use on a systems of equation that has 2 variables and a systems of equation that has 3 variables. So after we learn what's called Cramer's rule, you'll now know elimination, substitution, graphing, Gaussian elimination with back substitution, Gauss-Jordan, and now Cramer's rule, okay? If the directions, and I promise you directions on your test are going to say use Cramer's rule. If the directions say use Cramer's rule, you got to do it this way. If you've got extra time, you can check it using the other methods, okay? But if it says use Cramer's rule, you got to use Cramer's rule. So Cramer's rule works like this, okay? You're going to start with a system with 2 variables and 2 equations, which means 2 rows, 3 columns. You're going to find, for a 2x2, you're going to find 3 different determinants. The first determinant, so I'm going to label these underneath there because I think it's a little bit easier to understand. The first one you're going to find, we will just call D, which is made up of your x's and your y's. So it'll be x1, y1, x2, y2. What this is the coefficient. So they use a's and b's because it's the coefficients in front of these, okay? Then you're going to find d sub x. And to do this, whichever one you're finding, you take out the column that has that letter and replace it with its constants. So I'm taking out the x's and I'm putting in the constants. So the constants go in the first column. The y's stay in the second column. And then I have to find d sub y. I'm finding y, so this time the y's come out, the constants go in, which means the x's stay where they are, and the constants take over the place of the y's. And then you actually go through the little, fish motion, find the determinant of each of those, and then the x, this is your d sub x over d, this is your d sub y over d. So to find x, you put d sub x over d, simplify it, it will be a number. To find the y, you do d sub y over d. Again, simplify it, it will be a number. You could get no solution on the system just like this, and the way that happens is that your initial d determinant is 0, okay? So if you get a 0, you're going to end up dividing 2 things, but you can't do it, right? It's undefined. So that's the way that you would see a no solution in this type of problem. All right, so use Cramer's rule to solve the system. First thing I'm going to do is rewrite it in matrix form. So this is 2, -3, -11, 1, 2, 12. So we operate just with the coefficients from here on out. So the first one is D. D is the x's and the y's. So 2, -3, 1, 2. I'm going to come back and do the determinant. We're just going to set it up first. Then I do d sub x. From that first d1, I take out the x's. I put in the constants. So -11, 12, -3, 2. From the third one, I take out, looking at the initial one, I take out this time the y and replace it with the constants. So the x's stay, constants replace the y's. With me so far? So now I got to do the determinant for each of these, right? So work my way around. This would be 4 minus a -3 becomes 4 plus 3, or 7. Around here, this would be -22 minus a -36. -22 plus 36, which is 14. 24 minus a -11 becomes 24 plus 11, or 35. And then the x is d sub x over d, which is 14 over 7, or 2. The y is d sub y over d, or 35 over 7, which is 5.
Are they mostly
I would say more often than not they're whole numbers, but not every single time.
But like if they aren't, would you just keep it as a function?
Yeah, so if it was like a 1/2 or a 5/2 or something like that, you can just keep it there as long as it's simplified. Yep. Questions? And again, knowing that you know how to solve a system other ways is fine if you've got the extra time to go back and check it. Just make sure you make it through all of your stuff first, okay? All right, so D should have been negative 16, D sub x, negative 16, D sub y, 32. And then x would be 1 and y would be negative 2. Negative 16 over 16 and 32 over negative 16. Raise your hand if you got away. Okay, good. All right, so I'm going to show you how to get this on the calculator so you can check your answers. Remember last week we talked about that you could plug in a system into a matrix and then find the answer to it using a graphing calculator? So this is how you do it. All right, so the first thing I would do is I would figure out what my augmented matrix is, which is this first thing. 3, 2, negative 1, 2, negative 4, 10. And then I would plug that into the calculator. So I'm going to go to second matrix, back to my menu. I'm going to go to edit. That would be a 2 by 3. So I made it a 2 by 3. And then I entered in 3, 2, negative 1, 2, negative 4, 10. Then I'm going to go to second, quit to get out of that mode. And I'm going to go to my matrix math menu, which is actually under second matrix. And I arrow over 1. And then you're going to scroll all the way down to RREF, which stands for reduced row echelon form. I'm going to hit that. I'm going to bring back my matrix, which was A. And I hit enter. And it's going to give it to me in reduced row echelon format, which is 1, 0, 1, 0, 1, negative 2. Okay, that would be x equals 1, y equals negative 2. Questions on that? So obviously this should be helpful for you to check your answers on your homework. You're not going to have a graphing utility on your test. Okay, I'm not that nice. All right, now we're going to talk about it with a 3 by 3. So it's almost exact same process, except now you've got 3 variables, which means your initial system has 3 rows, 4 columns, because you've got your x's, your y's, your z's, and your constants. This time, instead of just finding d, d sub x, and d sub y, you got to find d sub d, d sub x, d sub y, and d sub z. And each time there's 3 columns, which means you're doing a 3 by 3 determinant 4 times, okay? So the first one is your x, your y's, your z's. That's what this one is. These would be my x's, these would be my y's, these would be my z's. That's just d. D sub x, you remove the x's and you put in the constants. So here's my constants, here's my y's, and here's my z's. D sub y, you leave your x's and your z's and you replace the y's with the constants. And D sub z, you leave the x's, you leave the y's, and you change the z's to be the constants. So again, whatever column the initial one is located in is the one you replace with the constants. Don't rearrange these. And then for x, you would do d sub x over d. For y, d sub y over d. And for z, d sub z over d. Super fun, right? Although if you had a choice between how to solve a 3 system or 3 variable, right now you'd have the new 1, new 2, the one we learned in the very beginning, right? You'd have Gaussian elimination with back substitution. Gosh, Jordan, or this. Honestly, sometimes I'd pick this. Maybe the new one, new two. But this for me is like a sure bet. Okay? It's not puzzled to figure out like the matrices are. All right, so use Kramer's rule to solve it. First thing I'm going to do is create my initial matrix. Just my constants. So -2 is in front of the x, 1 is in front of the y. There is nothing there for z, so you have to put the 0. You got to have the placeholder. And then 1 for the constant. 1, -1, -2, and 2. And 3, 1, 0, and 6. There's my augmented matrix. So D is the x's, the y's, and the z's. I'm going to come back and do these determinants in a minute. D sub x, I replace the x's with the constants. So 1, 2, 6. The y's stay the same. The z's stay the same. D sub y, the x's match my original ones. This time the y gets replaced. And D sub z, the x's match the original ones. So the z's get replaced. Okay, then I'm going to go through and do the individual 3x3 determinant 4 times. So the first time, duplicate it to the right. Diagonals, top left, bottom right. That would be a +2, -6, and 0. Oh, sorry, that's not a 2, that's a 0. -2 times -1 times 0 would be 0. 1 times -2 times 3 is -6, and 0 times 1 times 1 is 0. And then go back the other way. 0 times -1 times 3 is 0. -2 times -2 times 1 is +4. 1 times 1 times 0 is 0. And then I get 0. Nope, that would be -6. -6 minus 4, which is -10. Then I go to the next one. So 0, -12, 0. That's -12. Back the other way. 0, -2, 0. And I get -12 minus a -2, which becomes +2. And that's -10. And then I gotta do D sub y. Zero -6, 0. 0, that's 24. 0. And the last one. So +2 times 6, 12. 6, 1. And back the other way. -3. And then once you get all the determinants, x would be D sub x over D, which is -10 over -10, or 1. Y is D sub y over D, -30 over -10, which is 3. z, which is d sub z over d, which is 20 over negative 10, negative 2. So my solution is 1, 3, negative 2. Questions on area, collinear, or Kramer's rule. All of them using the determinant of a 3 by 3. Okay, I am going to show you one more thing. I'm going to show you the alternative method of finding the determinant of the 3 by 3. I think in all of my classes I've had 2 people that want to use it. So I'm going to show it to you. If you don't want to use it, totally fine. Stick to the way it works, okay? But 1, it's a great way to check your work. 2, if that's what you want to choose over this one, totally fine. So I'm just going to grab the very first one, which is the negative 2, 1, 0, 1, negative 1, negative 2, 3, 1, 0. And I'm going to find the determinant of this matrix. So this is expanding using either a row or a column. The thing that I had you skip, okay, in 7-7. So basically what you're doing is combining your minors and cofactors with the expansion of one of the rows or one of the columns to find the determinant. You can choose which one you pick, whether it be a row or a column, okay? But you're going to pick one. So if I want to cancel out row 1, let's say, so this is called expanding using row 1. Then that's the row I'm going to find all of the minors of. So I'm going to find the minor of row 1, column 1, row 1, column 2, and row 1, column 3. How do I find the minor of row 1, column 1? Cancel out the row and the column that it's in, right? So I would cancel through these and find the determinant of what's left. Negative 1, negative 2, 1, and 0. And then I'm going to repeat that. I'll go back and do the determinant, but I'm going to repeat that for row 1, column 2, which would be 1, negative 2, 3, and 0. And for row 1, column 3, and I'd get 1, negative 1, 3, and 1. So I'm finding the minors of one row or a column. I picked row, but you could have also done this with column 1, let's say. So then this is 0 minus a negative 2 or 0 plus 2, which is 2. This is 0 minus a negative 6 or 0 plus 6, which is 6. And this is 1 minus a negative 3 or plus 3, which is 4. Then you have to multiply your minors by the numbers that you canceled out. So I'm going to go through here, and the first one I canceled out was negative 2. I'm going to multiply this times negative 2. The second one I canceled out, which I got the 6 for, was 1. So I'm going to multiply that times 1. And the last one is by 0. And then I'm going to find the sum of these 3. But first, I have to use the pattern of my cofactors of that row to see if I need to change the signs. So if you remember the cofactors of the row, which of the spots in your matrix do you change signs when you're finding your cofactor? The north, south, east, and west, right? These are the 4 places I would change the sign. Does that make sense? So I'm only using row 1, which means I am only going to change the sign on the second number. So I'm going to keep this as negative 4. This would have been a positive 6. I'm going to make that a negative 6. And this is a 0. Add them together and you get the determinant of that matrix. So if you always pick row 1 or column 1, then the pattern will always be keep the sign, change the sign, keep the sign, or plus, minus, plus. Again, should you stick with the diagonals, top left, bottom right, that's totally fine too. This is a great way for, if you have extra time, check it. But stick to whatever works for you. So as far as your test goes, which is Thursday, it's going to cover everything from the quiz, 7.5, 7.6, 7.7, and then the stuff that we just talked about today, 7.8. We'll spend the next 2 days reviewing, okay? The good news is, like, this is going to take the place of your 3x3 determinant. So it's not like I'm going to make you do a 3x3 determinant, and then the area, and then collinear, and then Kramer's rule, okay? That's a whole heck of a lot of 3x3 determinants. So this kind of stuff will take the place of that.